Assalamu alaikum. Yes, children, in the previous video we started third exercise, and out of the questions we did up to first part of second question that day in that video. Today we'll begin from second part of second question. We have to show some results, and you were told whenever you are asked to show something or prove something, you have to show LHS is equal to RHS. We'll consider LHS of second part. Here is second question, second part, and we'll consider its LHS. RHS of this part is 0. We'll simplify LHS and show this is equal to 0. We have cos 38, cos 52. Cos 38 degrees multiplied by cos 52 degrees. Then there is minus sign. Sin 38 degrees into sin 52 degrees. This is the LHS of that question. We have to show this is equal to 0, that is RHS. Again, like the questions we did earlier, question 1, 4 parts we did, question 2, 1 part we did. You were told angles here involved are not those specific angles. 38 is not among those, 52 is not among those. But these 38 and 52 have sum equal to 90, therefore these are complementary angles. We will use that procedure we used yesterday. Sum of these is 90. Let us consider 38 degrees plus 52 degrees is equal to 90 degrees. Then you were told that we will follow the procedure of transposing here the smaller angle. Yesterday also we did. Though you were told we can transpose larger angle also. For any one you have to transpose. We'll follow transposing smaller one. We'll get therefore 52 degrees is equal to 90 degrees minus 38 degrees. In the next step you were told to find out the trigonometric ratio with this isolated angle. 52 we have separated. With this 52, which trigonometric ratio is involved in the question? And as we find that, we find with this 52, we have cos here, but we have also sine with that 52 there. Therefore, in this question, you will have to use cos as well as sine. First, we'll do the part involving cos, and later separately we'll do the part involving sine. Let us first consider taking cos to both sides. Taking cos to both sides, we get it will be cos 52 degrees is equal to cos 90 minus 38 degrees. And it is here that yesterday you were told, last time you were told that you have to use that complementary relation, complementary angles relation. 6 relations were given to you. And out of those it is cos 90 minus theta that you have to use again. Cos 90 minus theta. Theta is 38 here. And when you look at that list of relations, cos 90 minus theta is sin theta. And since theta is here 38, therefore it will be cos 90 minus 38 is equal to sin 38. Therefore, we have cos 52 degrees is equal to sin 38 degrees. In the bracket, we'll write that relation we used. Cos 90 minus theta is equal to sin theta. This relation out of those complementary relations we used. And in this, theta is replaced by 38. So it is sin 38, it is 90 minus 38 cos, we have used it. This is the first part. Now next, since as I said earlier, with 52 we do not have cos only, we have sine also. Therefore we'll do that part also. In this part we took cos to both sides. You will now write also taking sine to both sides. We get. Now this time it will become sine 52. Earlier we wrote cos 52 because we had to take cos on both sides. Cos on both sides was written. This time sine will be written. It will be sine 52 degrees is equal to sine 90 minus 38. And then again you will compare this with the properties, relations, complementary relations. Previously it was cos 90 minus theta that was used, equal to sine theta. This time it is sine 90 minus theta that you have to use. That is cos theta. And again theta is 38. Therefore this will be sine 52 degrees is equal to cos 38 degrees. The relation used is sine 90 minus theta is equal to cos theta. We again replace the theta by 38 here to get this relation. And finally, like previous parts, in the question, LHS of the question, we'll use these two results. For cos 52, we'll write sine 38. For sine 52, we'll write cos 38. So this will be right now. Cos 38 degrees multiplied by cos 52 degrees minus sine 38 degrees multiplied by sine 52 degrees is equal to. Now use. For cos 52, write sine 38. It will be cos 38 degrees multiplied by sine 38 degrees. Use it first relation. Cos 52 is sine 38. So replace cos 52 by sine 38. Minus. Now use second relation. Sine 52 you have to replace by cos 38. It will be sine 38 degrees as it is multiplied by cos 38 degrees. So two results we used. And then we find both the terms are same. First term here is up to this minus sign, cos 38 into sine 38. Second also is sine 38 into cos 38. You can use commutative property of multiplication. Cos 38 into sine 38, this can become, and being same will cancel them. The result is 0. What is our RHS? Hence we have proved it. This is the solution of second part of second question or the third question. Question number 3. The procedure of solving question 3, question 4, question 5 will be same. Sixth also will have the same procedure, but some steps you will have to first do before you have the same procedure. Let us consider first third question. It is given that tan 2a is equal to cot of a minus 18. Tan 2a is given equal to cot a minus 18 degrees. This is given to us. We are asked to find the value of a. And also we have to show that condition that 2a is an acute angle is also fulfilled. 2a is an acute angle. We have to fulfill that condition also. But that can be done only after finding the value of a. To solve this question, again you have to use trigonometric ratios of complementary angles. Those relations you have to use. And when we look at those relations, tan and cot are related to each other. We have tan and cot involved. Sine and cos are complementary relations. Sec and cosec are complementary relations. So the questions will always have those complementary and trigonometric ratios involved. Either you will have tan and cot like here, or you will have question involving sine and cos, or sec and cosec. And then as we see, between tan and cot there are two relations. It's the rough work. First relation is tan 90 minus theta is equal to cot theta. This is the first relation. And the second one is cot 90 minus theta is equal to tan theta. Both these relations involve tan and cot. You have to choose one out of the two. This question involves relation between tan and cot. Given relation is between tan and cot. So out of the trigonometric ratios of complementary angles, 6 relations, you have to choose the relations involving these tan and cot, the ones which are involved in the question. And as we find there are two such. These are the two. Out of these two, you have to choose one. Now I will choose. Which one will choose? We will choose the one involving with tan a monomial. Because here also tan has a monomial. Therefore, in the relations out of those 6 relations, we'll choose that relation out of the 2 involving tan and cot, which has monomial angle with the tan. Because here we have monomial angle with the tan. We have here binomial angle with cot. Monomial angle with tan. Therefore, when we look at the relations, we find this second relation has monomial angle with tan. Here tan has binomial angle. So this relation will not use, we'll use this relation. So that we know cot 90 minus theta is equal to tan theta. This relation therefore out of those 6 we chose. And the reason you must remember why we chose this. Because in the given relation, tan has monomial angle, and here also tan has monomial angle. We would like to change now here the angle to the angle that is given to us, monomial angle 2a with tan. Tan has theta here. We would like to change here also the angle to 2a. To do that, you have to replace theta by 2a. So replacing theta by 2a, we get cot 90 minus 2a, theta I replace it by 2a, is equal to tan 2a. I replace theta by 2a. Thereby I got this tan 2a, RHS of this, same as what we have in the given, tan 2a. This will help us to eliminate this tan 2a from these by using Euclid's action. Therefore, as we eliminate tan 2a, we'll get cot 90 minus 2a is equal to cot a minus 18. We use it the given result here. Tan 2a I replace it by cot a minus 18. Now cot trigonometric ratio being on both sides will get cancelled. We will have 90 minus 2a equal to a minus 18. This is a linear equation in one variable. Solve it for a by transposing. 90 minus 2a minus a will be then equal to minus 18. I transposed a from RHS to LHS to combine it with 2a, it's like term. Signs are same, so add them. 90 minus 3a will be equal to minus 18. Then transpose 90 to other side. Minus 3a will be minus 18 minus 90. Minus 3a will be equal to minus 108. Minus minus will cancel. Thus A will be equal to 108 divided by 3, which is 36. This is the value of A. We were asked to find the value of A. The value we got 36. Having found this, we now have to verify that relation 2A is an acute angle. So when A is 36, what will be 2A? 2 into 36. For A we wrote 36, which is 72 degrees, lesser than 90. And when the angle is less than 90, it is called as an acute angle. Therefore, 2A is an acute angle. That completes our question number 3. And as I said, same procedure you have to use in solving 4th question as well as 5th question, and then 6th question also will have the same procedure. Let us now consider question 4. Question 4. This time what is given to us? Tan A is given equal to cot B. That is what is given to us. We have to prove that A plus B is equal to 90. This is given. And again here tan and cot are related. You have to again go to the 6 trigonometric relations we have of complementary angles. Sine, cos, tan, cot, sec, cosec. And then between tan and cot, the trigonometric ratios involved here, we again have 2 relations there. These are the ones I have not rubbed these earlier, because again tan and cot are involved. Tan 90 minus theta equal to cot theta. Cot 90 minus theta equal to tan theta. Out of these you have to choose one. Well, in previous question, the choice was made by using the trigonometric ratio which has monomial angle. We had on one side trigonometric ratio with monomial angle, on the other side we had trigonometric ratio with binomial angle. We decided to use trigonometric ratio with monomial angle and found where that same trigonometric ratio with monomial angle is in the relations also. But this time we have on both sides monomial angle. Therefore, you are free to use. You can use first relation, second relation, whichever you may choose. Right, we know. Tan 90 minus theta, I am using the first out of the 2, is equal to cot theta. And then in this, tan is binomial. Tan is having binomial angle. Cot is having monomial angle. So we'll make cot here same. In the given relation, cot has angle B. Here cot is theta. We'll replace theta by B therefore. Replacing theta by B, we get tan 90 minus B, for theta I wrote B, is equal to cot B. Well, I said, since we do not have any binomial angle in the given relations, we have monomial on both sides. Therefore, you are free to choose the relation. You may use first, you may use second, both are possible. And then, in the relation number first that I used, I then again found which angle is monomial. This was monomial angle. And that has trigonometric ratio cot. Therefore, from the given relation also, I found what is the angle with cot. It is B there, here it is theta, so we replace theta by B to get cot B equal to tan 90 minus B. Now use Euclid's axiom as in the previous question. Cot B will get eliminated. Therefore, we'll get tan A is equal to tan 90 minus B. Cancel tan with tan. A will be equal to 90 minus B. Then transpose B to get the final result. A plus B is equal to 90 degrees. That completes the solution of this question. This was question number 4. Now question number 5. Question number 5. Procedure is same, but this time trigonometric ratios have changed. We have sec and cosec involved this time. Sec 4a is given equal to cosec a minus 20. Procedure will be same, but sec and cosec are involved. Therefore, you have to use the, out of those 6 complementary relations, you have to use the ones involving sec and cosec. There are 2 such relations I will write here on the board. The first one is sec 90 minus theta is equal to cosec theta, and the second one is cosec 90 minus theta is equal to sec theta. Then you have to make choice out of the 2, which one, because again we have in the given relations on one side monomial angle, on the other side a binomial angle. We again chose the one with monomial angle. 4a is monomial, it has sec here, so therefore we'll use this relation sec theta, monomial angle sec theta. It is cosec 90 minus theta, so right, we know cosec 90 minus theta is equal to sec theta, and in this replacing theta by is monomial angle sec theta, sec 4a, so theta will replace by 4a. We get cosec 90 minus 4a is equal to sec 4a. Cosec 90 minus 4a is equal to sec 4a. And then when we compare this with the given relation, sec 4a will get eliminated. We will therefore get cosec 90 minus 4a is equal to cosec a minus 20. Cosec will cancel from both sides, leaving us with 90 minus 4a is equal to a minus 20. Again a linear equation in one variable. Let us combine like terms to solve this for a. 90 minus 4a minus a will be equal to minus 20. 90 minus 5a will become minus 20. Like terms we combined a and 4a. 90 will be transposed. Minus 5a is equal to minus 20 minus 90. Minus 5a will therefore become minus 110. Minus minus will cancel. A is therefore 110 by 5, which means 22 degrees. The value of A therefore is 22 degrees. Now knowing the value of A, we have to show that 4A is an acute angle. You can show that as we did in the previous case. What will be 4A then? 4 into 22, which is 88. It is less than 90. Therefore, it is an acute angle. 4A is an acute angle. That completes this question. So the questions are same. Next we have question number 6. Well, here is question number 6 now. In this question, we are given A, B and C are interior angles of a triangle. We are given interior angles of a triangle here. 3 interior angles, A, B and C. Then we have to show that sine of B plus C by 2 is equal to cos of A by 2. This result we have to show. Since we have a triangle, interior angles of the triangle are given, we'll begin therefore solution with angle sum property. You know, sum of the angles of a triangle, interior angles of a triangle is 180. So you write, since A, B and C are interior angles of a triangle, Therefore, their sum is 180 according to angle sum property. Angle A plus angle B plus angle C is then equal to 180 degrees, right in the bracket, angle sum property of a triangle. Out of these three angles, now we'll have to transpose one. Which one will transpose? Look at the result to be proved. We have on one side angle B and angle C, and on the other side angle A. So this will help you to understand what to be transposed. You have to transpose A because B and C are together on the same side. Thus you will get on transposing A, angle B plus angle C is equal to 180 minus angle A. That angle symbol is not written in the result to be proved. It does not make any difference. We will write it because it is an angle. So angle B plus angle C we got equal to 180 minus angle A. We transposed A because A is separated. B and C are together in the result to be proved. Then we find both these are divided by 2. B plus C is divided by 2. A also is divided by 2. So this helps us to understand that this relation you have to divide on both sides by 2. Right, dividing on both sides by 2. We get left hand side will become angle B plus angle C by 2 is equal to right hand side will become 180 minus angle A by 2. Then on the right hand side you will split it. Left hand side we need not split because it is angle B plus angle C by 2 in the result to be proved also. So we'll keep the same. Right hand side will split. This 2 will divide individually both 180 as well as angle A. It will be therefore angle B plus angle C divided by 2 is equal to, when you divide 180 by 2, that will be 90 minus angle A by 2 will remain as it is. Angle A by 2 will remain as it is. And at this stage, having done this much, we have to use the trigonometric ratio. The trigonometric ratio that you have on the left side in the result to be proved, B plus C by 2, we have B plus C by 2, it has sine trigonometric ratio there in the beginning. So that sine will apply on both sides. So right, taking sine to both sides. We get left hand side will become sine of angle B plus angle C divided by 2. This is the left hand side is equal to right hand side will become sine 90 minus angle A by 2. And here you have to use the complementary relation. It is sine 90 minus theta again. Instead of theta, this time we have angle A by 2. So use the relation sine 90 minus theta. It is cos theta. And theta is angle A by 2. It will therefore become sine angle B plus angle C divided by 2 is equal to cos of angle A by 2. Why? Because sine 90 minus theta is cos theta. Theta you have to replace by angle A by 2. Write as reason in the bracket because sine 90 minus theta is equal to cos theta. This relation we have used out of those 6 complementary trigonometric relations. By replacing theta by angle A by 2, we get sine 90 minus angle A by 2 equal to cos A by 2. That completes the solution of this question. Finally, we have the last question of this exercise. We'll do this also. With that, the exercise will be over and we'll conclude also with that. Let us do 7th question now, the last question of this exercise. Question number 7. In this question, we have to express sine 67 degrees. Sine 67 degrees plus cos 75 degrees. We have to express this in terms of trigonometric ratios of angles between 0 degree and 45 degree. Presently, this expression is in terms of angles which are greater than 45. 67 and 75, both are greater than 45. They are less than 90, they are acute angles, but greater than 45. We are now asked to express them in terms of angles less than 45, between 0 and 45. We have to change 67 to such a form where it will be less than 45, 75 also. And for that you have to again use those complementary relations. In earlier questions we did, each question we did involved complementary angles. Both angles were involved there. Angles were given there which had sum equal to 90. But this time you have to find yourselves the measure of the angle which will make complementary angle with 67 and later with 75 also. We can easily find complementary angle of 67 by subtracting it from 90. That will be 23. 67 degrees we know is 90 minus 23, therefore. 67 and 23 add up to 90. 23 is transposed here, so 67 is 90 minus 23. And then this will change to the shape of the expression, part of the expression in sine 67. We would like to have sine 67 here. To do that, you'll have to take sine to both sides. Taking sine to both sides, we get sine 67 degrees is equal to sine 90 minus 23 degrees. Then use the complementary relation. It is now sine 90 minus theta, that is cos theta. It will be therefore sine 67 degrees is equal to cos 23 degrees. Because sine 90 minus theta is equal to cos theta, right? In the bracket, the relation we used, sine 90 minus theta is equal to cos theta. In this relation, we have replaced theta by 23 to make this sine 90 minus 23 and this as cos 23. That is first part. Now second part, you have to use 75. 75, what will be the complement of 75? Like here, 23 was complement of 67, 15 is complement of 75. So we'll write again 75 degrees is equal to, this time 90 minus 15, because 75 and 15 together make 90. And now which trigonometric ratio you will have to take? So look at 75. It is cos 75. So taking cos to both sides. We get cos 75 degrees is equal to cos 90 minus 15 degrees. And this time it is cos 90 minus theta relation that you have to use. Earlier we used sin 90 minus theta relation. Now you have to use cos 90 minus theta relation. This will give us therefore cos 75 degree is equal to sin 15 degrees. Because cos 90 minus theta is equal to sin theta. And these results then we'll use in the given expression to get the final result. Right, therefore sine 67 degrees plus cos 75 degrees is equal to cos 23 degrees. Instead of sine 67 degrees we wrote cos 23 because we have proved they are equal, plus sine 15 degrees. In this way we have changed this given expression to the form where angles are less than 45. 23 is less than 45. 15 also is less than 45. With that, this exercise comes to end. We will conclude the day.